We're going to start looking at descriptive statistics, summarizing and graphing data, and this is material in the chapter 2. And the first couple of things we'll look at is frequency distributions and histograms, and also a few basic statistics. We'll start by looking at a bunch of raw data. This is time that customers waited at McDonald's. There's not much you can do with raw data, but a couple of simple questions you might ask. What's the fastest that any customer got through? What's the longest that a person waited? And the range, okay, the max minus the min. Okay, well, you could look through this list and try to pick out the minimum, but we're not going to do that. We're going to use technology always. So what you're going to do is go over to my stat lab. Once you sign into the site, you'll see on the left Stat Crunch, and we're going to select that. So we're going to use technology to do the basic statistics here. And you're going to want to select data sets from your textbook. So this McDonald's data is in the fast food data set. Okay, we'll come over here. I'll widen this column out a little bit, and this is the McDonald's lunch data that we were just looking at. Okay, so it's still, and some other data, fast food data. You can see it's still just raw data. We can't really see what the max or minimum is as it is. So one thing that we can do in StatCrunch is sort the data. And if you look at the data tab, you'll see one of the selections is sort, and then you're going to select McDonald's lunch. We want it ascending, and there it is. It forms that new sorted data in a new column here. It's called sort McDonald's lunch. So there's our data. Now we can just see that the minimum is 83, and then the max is down here at 308, and also there are 50 data points. But we don't even need to do that by hand. We can actually compute the min and the max using the stat, and we'll be using this to for lots of other statistics, and these are all called descriptive statistics or summary statistics. So we want summary stats on the column. And we're going to select McDonald's lunch, or we could select the sorted. It doesn't matter because it's the same data. And we'll just select all of those statistics. Right? We don't know what all of them mean. Maybe we know what some of them mean. But we can see the min, the max, and the range right there. Now we can X off this data if we want, and it disappears into this tab here, and we can pull them back out if we want. So we have the summary stats here. We can pull that back out if we want to look at it. Okay, so we have the min, the max, and the range here. Right? Well, the next thing we want to do is divide the data up into classes and see how many observations lie within each class. And if we do that, we get what's called a frequency distribution. And here's an example. So there are 11 values, there are 11 customers that waited between 75 and 124 seconds, and so on and so forth. Already you can kind of get a sense of how the data lays out. You can see most of the observations are in here, so between 125 and 224 seconds. We can get a nice visual display of this frequency distribution in what's called a histogram. So let's come over here and do that using the graph menu. I'll get rid of the statistics here. Let's use the graph menu and select histogram. And we want McDonald's lunch again. Doesn't matter if it's the sorted or the original. And we can ignore these selections for now. We want a frequency distribution histogram. And with the bins, we'll select starting at some number lower than our minimum. Our minimum is 83. I'm going to select 75. And I'm going to select the width of each bin to be 50. We'll get a nice visual display of that data. It's the same information in the frequency distribution, but now it's displayed graphically, and we can see at a glance where most of the observations lie. We got a few customers that waited a longer amount of time, and you can see in StatCrunch here, if you mouse over the bin, you get the frequency and the range of that class. The number of classes in the class width is up to you, or you're told what to do in the problem. We might get a different picture depending on how we set this up. In fact, you can let the software decide what to do and see what kind of a picture you get. So notice we get a different picture. It looks qualitatively the same, but we've got what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 classes here, where we only had 5 over here. So you get a different picture depending on how many classes. And with more classes, of course, the class width is less. Simple recipe for creating a histogram or frequency distributions. You're going to select the number of classes. It's somewhat arbitrary. There are some guidelines. Once you know the number of classes, to find the width of each class, you're going to take the range divided by the number of classes. Typically we round up. There are a couple reasons for this. We want to make sure we cover all the data, and often we use more convenient numbers if possible. We're going to select a starting point. Now typically we're going to select a number less than the minimum. Certainly we have to select the minimum at least, but a convenient number, how about 75? Again, it's arbitrary, and we're going to get slightly different looking histogram, but qualitatively they'll be the same. To get the lower limits of each class, you're going to add 50 successively. So the second class starts at 125, then the third one starts at 175, and so on and so forth. So then we're going to get all the left-hand endpoints of the classes, and then it's easy to find the right-hand endpoints. So the right-hand endpoint is just going to be one less than the left-hand endpoint of the next class. Now if you have decimals, it's a little bit more complicated, but this is essentially what's going on. We can also notice that these numbers are all going to add up to 50. So you have 11 observations here and 24, and we know that there are 50 total. If we divide each of these numbers by 50, we get what's called the relative frequency. Okay, and we can also plot a relative frequency distribution. The numbers over here are just the frequencies divided by 50. All right, and then we can express those as a percent if we like. The histogram is going to look exactly the same, and I've done that in StatCrunch. You can see these two histograms look exactly the same. It's just the vertical axis has been rescaled. So all of these numbers over here, the frequencies, if you divide them all by 50, you're going to get these numbers. So it's essentially a rescaling of the axis. Relative frequency distribution communicates more information because it's more helpful to know that 48% of the customers versus 11 or 24 of the customers. So in this video we looked at some statistics. We also looked at frequency distributions and histograms, really different displays, ways to display the same thing, and we did a little bit of StatCrunch. More to come in class.